All right, so we're going to talk about indicators, pH indicators, acid-base indicators, but first I wanted to remind you just a little bit about acids and bases. So in the middle you have the pH scale from 0 to 14, which is it usually runs. And then here you see on this side the hydrogen ion concentration. So the more you have, the lower the pH, and the less you have, the higher, excuse me, the pH. And then exactly opposite of that is the OH minus concentration. The fewer OH minuses, the lower the pH or the more acidic, and the higher the OH, the more alkaline. So just reminding you of those facts. All right, so pH indicators. Indicators are a substance that changes color as the pH of a solution changes. Most indicators are organic molecules, meaning they consist of carbon atoms, and they are considered weak acids that have a color when in solution. Now they either become colored when they have excess H plus ions or when they lose H plus ions. So here's an example. And you see down here, this is the indicator, the H, MEOR. And then over here, MEOR minus. Okay, so the H has fallen off. So this is the basic form and the acidic form. The acidic form is red, the basic form is yellow. Okay, so that's what we see in that solution. Some indicators are going to only have two color changes, while others are going to go through an intermediate color between the quote-unquote in colors. Depending on the pH of the color change, an indicator can help you differentiate between an acid, a base, different degrees of acidity, or different degrees of basicity. So here we see a list of common indicators. The indicators with the H on them would be present at the lower pH, and then the basic forms with the H removed would be at the higher pHs. You see methyl violet changes color at a very low pH, and thymol blue is going to be purple at a pink rather at a very low pH, and then a purpley color at a higher pH. Right? Methyl yellow has a color change around pH 4. Bromothiol blue is pretty much the exact opposite and has a color change around the same pH, but it's a different. The bromophenol blue is going to be blue in more basic solutions, and the methyl yellow is going to be in more acidic conditions. It'll have a color. All right, so you see, and then you see over here you have some that have the intermediate colors that they go through. Okay. The various indicators lose and gain hydrogen ions at different pHs because remember, they're all weak acids. So the pH of their transition is dependent on the Ka, or the equilibrium constant for that weak acid that is the indicator. Indicators often are used in titrations to indicate the endpoint between an acid and a base. And the selection of the indicator depends on the pH of the final product. So you need to know if you're dealing with a acidic salt, a basic salt, or a neutral salt when you're selecting your indicator so that you get the one that's going to give you the best results. Here's a general equation for an indicator. So H indicator plus water is going to make hydronium ion and the basic form of the indicator. The acid form and the basic form are different colors, and they change colors as a result of either gaining or losing those hydrogen ions. The thing that's super important to point out here is remember that they're all weak acids, so their Ka depends on which pH they're going to actually change colors from the acidic to the basic form. When you're selecting indicators, you would like to select one that has a transition change or a color change at about 1 unit above your pH at equivalence. So here's your equivalence. This is obviously a strong acid, strong base because the pH at equivalence is 7. So you can choose either methyl red or thymol blue because they change pH about one pH unit away from the equivalence point. Now over here, you see that this one actually is not as good because methyl red would change color before you actually reached equivalence, and then thymol blue would change actually a little bit after. Okay, so it's not good here because it's not within 1 pH unit of when they actually change color. So we would need to reevaluate and use some different indicators when we were dealing with that. All right, now notice that the equivalence point is above 7, so that means we made a basic salt, which means you had a strong acid and a strong base and a weak acid. All right, here's a huge chart with all the indicators you probably could ever think of. There are, of course, more. One that's really popular that's not on the list is called universal indicator. Universal indicator actually shows a rainbow of colors. That's because universal indicator is not one indicator. It's a mixture of indicators that all transition at different pHs because they all have different Kas. So that's why universal indicator is something that we commonly use because it can transition at several different points. So it's very important to pay attention to your pH transition range when you're looking at an indicator for a specific acid-base reaction.